Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Understand the reaction mechanism. When SOCl2 reacts with an allylic alcohol via a 6-membered cyclic transition state, TS, it proceeds through an internal SN2-like SNE mechanism involving a cyclic sulfite intermediate. The 6-membered TS leads to allylic rearrangement with inversion retention depending on geometry. Moving on to the next step. Analyze reaction A. Reactant A is CH3. CH is equal to CH, CH2O, but 2N1-ol, i.e., the O is at C1 double bond between C2 and C3. In a 6-membered cyclic TS with SOCl2, the chlorine is delivered to the gamma carbon, C1 is equal to original O carbon, or via allylic shift to C3. The 6-membered TS involves OSOCl and the allylic system. The cyclic TS causes the Cl to be delivered to the allylic position away from the original O, i.e., an SN2 allylic rearrangement. The O is at C1, CH2O, so through the 6-membered TS, Cl ends up at C3 giving CH3, CH, Cl, CH is equal to CH2. Wait, let me reconsider. The substrate is CH3, CH is equal to CH, CH2O. The O is at C4, terminal CH2O, double bond C2, C3. In the 6-membered cyclic TS, the sulfur is bonded to O at C4 and the Cl is delivered to C2, gamma position via allylic shift. This gives CH3, CH, Cl, CH is equal to CH2. So P is equal to CH3, CH, Cl, CH is equal to CH2. Moving on to the next step. Analyze reaction B. Reactant B is CH3, CH, or CH is equal to CH2, but 3N2-ol, or at C2 double bond C3, C4. Through the 6-membered cyclic TS, the O is at C2 double bond at C3, C4. The Cl is delivered to C4, gamma position, giving CH3, CH is equal to CH, CH2, Cl. So Q is equal to CH3, CH is equal to CH, CH2, Cl. And for the final step, P is equal to CH3, CH, Cl, CH is equal to CH2 and Q is equal to CH3, CH is equal to CH, CH2, Cl. Verify option A. P and Q are position isomers. P is 3-chloro but 1Na, Cl at C3 double bond C1, C2. Rewritten CH3, CH, Cl, CH is equal to CH2 means Cl at C2 counting from methyl end, i.e., 2-chloro but 3Na or but 3N2 vial chloride. Q is 1-chloro but 2Na, CH3, CH is equal to CH, CH2Cl. Both have molecular formula C4H7Cl with one double bond. They are indeed position isomers, same molecular formula, same functional groups, different positions of Cl and double bond. So option A is true. Verify option B. P shows geometrical isomerism but Q does not. P is equal to CH3, CH, Cl, CH is equal to CH2, the double bond carbons are CH is equal to, bearing H and CH, Cl, CH3, and is equal to CH2, bearing two H's. Since is equal to CH2 has two identical substituents, both H, P does not show geometrical isomerism. Q is equal to CH3, CH is equal to CH, CH to Cl, double bond carbons are CH is equal to, bearing H and CH3, and is equal to CH, bearing H and CH to Cl. Both carbons have different substituents, so Q does show geometrical isomerism. So statement B says P shows geometrical isomerism but Q does not. This is false, it's the opposite. Option C gives P is equal to CH3CH, Cl, CH is equal to CH2 and Q is equal to CH3, CH is equal to CH, CH2, Cl. This matches our analysis. True. Option D gives P is equal to CH3, CH is equal to CH, CH2, Cl and Q is equal to CH3, CH, Cl, CH is equal to CH2. This is the reverse of what we derived. False. Therefore options A and C are correct, matching the given answer A, C. Therefore, the correct answer is A, C. The correct answer is shown on screen.